I've built the first Iron Man helmet with a fully functional heads-up display. So what does fully functional mean? How close did I actually get to Iron Man tech? I'll give you a sneak peek, then we'll get right to what I've spent the past 2 years working on. Here's a shot of the display. This is what I actually see in the helmet, and this is the arc reactor that runs it all. I'll show you how it works and even some of the things you can't see in these shots. I'm Chris, and this is Kersey Fabrications. Tony Stark,
genius, billionaire, playboy, philanthropist,
invents a suit of armor to initially counter the threats that his company has released into the world. The first suit was designed to save his life after his own tech almost killed him. From there, he develops the Mark II, which then morphs into the Mark III, a beautiful piece of engineering that to this day contains technology we can't recreate. But I believe we're a lot closer to some of this technology than anyone probably realizes. So I set out to show what was possible. This channel, up until this point, has focused on 3D printing, but I have bigger dreams. I've been an embedded software developer for over 20 years, and I want to show that a lot of what we see in Iron Man and other sci-fi movies is possible. In my mind, this whole project begins with the user interface to the Iron Man suit. In the movies, Iron Man's HUD, or heads-up display, is presented as a holographic display that he sees inside the helmet. It's a fantastic vision of what may be possible one day with volumetric holograms, but for now, we'll have to settle with flat panels that simulate this experience. We know a lot about how the brain perceives 3D graphics and how we can use stereo vision to achieve similar results. We have two eyes, and using the difference between those inputs, that's how we perceive depth. This is how modern VR headsets work, so we know this tech is already possible. For this to work in the real world, we'll need two cameras and two displays, one for each eye. This is augmented reality. For this whole experience to feel as awesome as Iron Man's tech, this experience has to be real-time, or in computer terms, low latency. It also needs to be high resolution and high frame rate. So what else will this computer have to do? If we look at one of these displays, we see a lot of graphics on the screen. So we'll need a reasonably fast graphics processor to display all of this on the screen and hopefully animate the graphics so they look like the film. And from the very first version, his helmet had object detection, meaning the helmet's UI could tell Tony what he was looking at and provide additional information. Now we're really talking about needing some processing horsepower. So where did I start this project? I came up with some basic requirements to make this feasible, but once I had that in place, the realization that what I was going to be asking a reasonably small and portable computer to do was quite a lot. So was there an embedded computer on the market that could even begin to do everything I was asking it to do? Time to check out my first vlog on this project. So I think this thing's on. Looks like it's on. Okay. So this is the very beginning. This is what I'm calling day one of the Iron Man real heads-up display build. And what I'm going to show you in this video is basically what I'm starting with. So I'm going to show you the hardware that I chose to get going with, and we'll go from there. So here we are. This is basically my Mark I Jetson Nano setup. So let's talk about the parts that I have here on the table. So first of all, we have the actual Jetson Nano itself. This is an NVIDIA chipset, all-in-one processor, silicon on chip, whatever you want to call it. And what this has on it, this is basically an quad-core ARM processor with basically a pretty nice NVIDIA graphics chip on board. It's an all-in-one single-board computer. Also plugged into this board, as you can see, I've got an ITX 477 camera, and this is a really high-end chip. It takes excellent images. I have another mount right here because we're going to be doing stereo vision. Let's take a look at what this looks like. So as you can see, here is the camera footage. As you can see, you're looking at the back of my garage and the mess that comes with that. This is a really good stream, and you can tell like this is almost real time, which is really what I was looking for. So now that we have the camera working correctly, I want to give you a demonstration of what the object detection looks like. And there we go. So as you can see, it is detecting me as a person. I'm getting about 21, 22 frames per second at this resolution. Now you'll notice one thing is I lost a little bit of real-time movement, particularly if I go fast. That's not going to be good enough for what I want to use it for. See, does it know this is a keyboard? It knew that earlier. There it goes. There, it does know it's a keyboard. So again, this is the basis for what I'm going to be working on. I hope this was a good first step to kind of show you what I'm thinking. This is going to be a journey. I'm hoping it goes relatively quickly. That's what I got here. So I'm going to do some becoming Iron Man here. With that first test completed, I had enough confidence that there was a chance I'd have the technology to make this work. I wasn't sure how much I'd be able to accomplish my performance goals, but that gave me enough to press forward. So I ordered the much more powerful NVIDIA Xavier NX. It was the same size as the Nano, but offered a lot more power. While I was waiting on that, I turned to the data the heads-up display would actually need to present. What kind of sensors would I need to be able to actually accomplish everything you see in the HUD? And before I could answer that, I'd need to decide which Iron Man helmet I was going to try to replicate. As I started going through the different displays shown throughout the series, I noticed that as we get further and further along, Jarvis really takes over and just shows Tony what he needs to know. And while I'd love to get there eventually, I needed to start with something that was a bit more utilitarian. So I went back to the beginning, the first helmet with the heads-up display, the Mark II. This helmet is originally designed based on the HUDs in modern aircraft and is really the most functional. Let's go over what's in the Mark II's HUD. While in flight modes, here's what we see. On the far left is the altitude, and next to that is the pitch or the up-down angle of where we're facing. On the top of the screen, we have the heading, or what's more commonly referred to as the compass direction. Right under that, we have the speed in relation to the speed of sound, or Mach speed. And then in the upper right, we see data readouts that we can use as a template for any of our text-based displays. In the lower right, we have some sort of radar that I think would be best used as a GPS to show where we're located. Finally, in the center of the screen, we have two things. First are the lines that show your roll or tilt angle. The line stays level with the horizon. Second, we see a reticle that locks onto interesting objects and points out to Tony useful information about them. This is the object recognition I had previously mentioned. How do we get what sensors we need from this? A GPS can provide both GPS coordinates and the current altitude once it's locked on. The pitch, roll, and compass heading can all be acquired from what's called a 9DOF or 9 degrees of freedom sensor. This allows you to capture 9 distinct types of motion or orientation related data, 3 degrees each of acceleration, magnetic orientation, and angular velocity. We're going to ignore the speed aspect for now because, at least initially, I don't plan to move fast enough for this to have any real use. Plus, I want to make sure that it's accurate once I do implement it. Finally, I'm going to want to display the environmental data inside my helmet to monitor my temperature and humidity. If it's getting too hot in the helmet, I want to know about it. I'll also throw in system information such as processor and memory usage. One last thing I'm going to need is a processor to control all of these sensors and send the needed data back to the main computer for display. There's actually a lot going on this little computer, with each device requiring its own libraries and processor-intensive work to turn the sensor data into position data. Then I'll need plenty of memory to turn all of that into something that my main system can understand. The most common choice for something like this is a little 8-bit processor, like an Arduino Uno, Mini, Micro, or Nano. While I love these chips for simple projects, the limited feature sets, processor speed, and memory really were non-starters for a project like this. So I turned to the Teensy 4.0. Why the Teensy? It's an actual 32-bit processor, has 2 megabytes of flash storage, and 1 megabyte of RAM. Let's jump back to that new NVIDIA board real quick. The Jetson Xavier NX not only had a lot more performance, but also a couple of killer features, such as built-in Wi-Fi and the ability to add a solid-state hard drive, which is great for both performance and storage capacity. It turns out that this board was not only a nice upgrade, but an absolute necessity for everything I wanted it to be able to do, particularly the 8 gigabytes of memory. So that's the processing power and sensors behind making this work. Now let's turn to how I'm actually going to be able to display this in a tight helmet. The key to my idea was not to deconstruct something, such as a VR headset, but to actually source some LCD screens and build the entire mount from scratch to fit inside an existing helmet. So I turned to my favorite inexpensive electronics site where I can find a ton of options in one location, AliExpress. Here's what I needed for the display. First, it has to fit in the helmet, and second, it has to be able to reliably connect to the Jetson board. Finally, for the displays to be as clear as possible, I wanted the highest resolution available and to make sure it was super smooth, I needed a high refresh rate. After a lot of searching, I found these. 2.9-inch DisplayPort connected, 120 Hz refresh rate, 2K dual LCD screens. Perfect. Here's how my first run with these went.
I'm going to get a display. It does know the resolution. It does see a 2880 by 1440 display. Let's click apply. And look, yes, that is absolutely amazing. And right now what I've got here are two displays with each half of the display being split over. And I think this is probably going to be how I actually run this. Look how clear that display is. You can really use that because of the number of pixels on here. So now you can actually see the display taking up the entire screen. Notice this is exactly what I'm looking for. I'm going to move my hand. You can see my hand. So I have a left and a right camera attached to each display. So this gives me a proper stereo heads-up display, exactly what I was looking for. So this is super exciting. Look how sharp it is on camera. Think how well this is going to look when it's right up against your eye, or at least as close to your eye as you can get with the lenses that are available. Just glorious. And that's one of the reasons that these displays look so good. Notice you're not getting any flicker on the camera, I believe. I think I could talk about this all day, but I'm really excited about this. Anyway, there we go.
Then I began to think about how I would connect all of these components between the helmet and the computer. I had it in my head that I was going to develop my own cable that would connect between the mainboard to the helmet. The idea was that I could make a single slim cable that would send all these camera signals. Seriously, I was trying to make this easier to connect. So I went through the trouble of finding a cable with what I thought were enough wires and then moved to make my very first PCB. I had never done this before and proceeded to learn the software, figure out the components I needed, and then I searched for someone to make these new boards for me. Not only did I need someone to produce the physical PCBs, but I was using components that I did not have the tools to attach to the board. I needed a company that could assemble the boards for me. After some searching, I ended up ordering from PCBWay. And while they are the sponsor of this video, this was well before we were working together. They legitimately had the best services, best prices, and best turnaround time. So I placed my order on their website. We went back and forth as they made sure that they produced exactly what I wanted, and in a short time, I had these in my possession. These were beautiful parts to me. They were my first PCB. They have my name on them. Everything about them was to my specification. The quality was fantastic. The soldering was clean, and they didn't work. When I plugged in the first connections, the components began to heat up and nothing worked like it was supposed to. It turns out my understanding of the wiring of the USB-C cable was flawed. Why am I telling you this story and why in the middle of an ad for my sponsor? This is a story of a failed idea, something that didn't work as expected, but the products and services that PCBWay produced were flawless. I couldn't have been happier with their site, their communication, and their pricing, which made this failure not such a huge loss. So thank you to PCBWay for providing me exactly what I needed to test out a theory, allow it to be successful or unsuccessful, and to keep it all affordable and produced quickly. If you'd like to check out all of their services, which go way beyond PCBs, go to PCBWay.com for your next project. All of the work on this helmet wasn't simply picking out hardware, wiring it up, and writing a lot of code. I also had to handle all the mechanical work of mounting all of this inside the helmet and finding out how I would wear the computer to make all of this portable. The first piece I worked on was the display and camera mounting. The cameras had to be placed in pretty much the same location as my eyes for my brain to easily accept the inputs. The displays needed to also be right in front of my eyes in order to take up as much of my field of vision as possible. So I came up with the design where I would mount the displays on one side and mount the cameras and all of the other needed components on the other. This all-in-one design allowed me to easily test and iterate the 3D models. It also made the next step more streamlined. How would I fit all of this inside a helmet without greatly increasing the size of the helmet? I could have started with any number of Iron Man helmets. I chose the Mark III because it's my favorite suit, and since I'm starting from the beginning, it made sense. From there, I needed to choose a model of that helmet that was easy to work with during my design process. Ultimately, I decided on Do3D's Mark III helmet, not because it's the most accurate, it isn't, but because it comes in one piece. This makes scaling and printing it a lot easier. The first thing I did was print out a helmet that would fit my head, then getting the camera and display mount to also fit in there. Once I had manually made sure everything would fit, I went on to model it digitally. This allowed me to keep iterating and resize it as needed. One of the other engineering must-haves for this was modularity. Throughout the process, I didn't want to glue in any of the components. It makes servicing or replacing anything really difficult. So that meant thinking ahead, designing mountable components and installing these incredible melt-in threaded inserts. This made working with the helmet really easy as I went from one modification to the next. And I had a lot of modifications. While it's not always the most glamorous part of the process, I have to talk about the software design. This is where over half the work on the project was, and for me, it was the most exciting and interesting part. The software is what takes all of these discrete hardware components and makes them into a remarkable system. It all starts with the core of the system, the NVIDIA Jetson, running the Linux operating system. Linux is my playground and what I've spent over half of my life becoming an expert on. Let me briefly go over the main components of the software. The cameras are connected directly to the processor over an interface called CSI, or Camera Serial Interface. This provides the bandwidth needed for high frame rates and high resolution. To access the cameras, I'll use a library provided by NVIDIA that connects through a larger set of libraries called GStreamer. In short, GStreamer allows me to chain together plugins to get my video streams in exactly the format I need. On top of the camera feed, I then need to display all of the cool graphics. I could have done this in one of two ways. I could have decided to learn 3D modeling and design an actual 3D animated display. While this could have potentially looked amazing, it would have taken much longer to model, code, and animate. It would have also taken more processing power and memory to render, two resources I knew would be in short supply. So I opted for easier to process and render 2D graphics that we could make look amazing with the right artist. More on that in a minute. So I used a library I had experience with, Simple Direct Media Layer, and I was actually able to get started coding fairly quickly, although I had to learn a lot of cool new tricks along the way for quality and performance. One of the major features I wanted in the helmet was to not only enjoy this myself, but to also be able to share the experience with others. This originally was just the idea of recording the video to disk so that I could show it online. After I wore the helmet for the first time in public though, I decided I wanted people to be able to see this in real time. So I decided to create a live stream that I could capture on a remote display and show those that were curious. I do both of these by, again, turning to GStreamer. I capture each of the frames from the display and then encode that and either send it to disk, to a remote network address, or both. While this is the last stage of the whole system, this is what makes it worthwhile. Sharing all of this is the best part. It's time to talk about one of my favorite parts of the entire project, the amazing graphics. When I started this project, I had some ideas about how I was going to replicate the graphics from the movie. Crappy crayon graphics by me, because I'm not an artist, pay someone on Fiverr and hope I can get what I needed, and then there's what I decided to do, ask the community for help. This resulted in the best possible outcome. An amazing artist and video game animator, J6, came to help me out. His work can be seen in every frame that's displayed in the headset. He helped me with design, he taught me about video game animation formats, he made amazing art that fit exactly what my vision was. It was amazing to see him crank out all of this work, and I can't thank him enough for his contributions. You'll find a link to his Twitter account in the description. Now back to the hardware part of the build. With the helmet sorted out and the software in place, the last thing I needed to do was decide how the computer was going to fit into the suit. I returned to Iron Man again for inspiration. When Tony was working on the Mark II, he took the tech he was working on and simply strapped it onto his body. So I turned back to Fusion 360 to design my arc reactor. This one is inspired by the movie and designed around fitting all of the components of the Jetson Xavier inside. Out of everything I designed, this one came together the easiest and with the fewest revisions. The functional part of the design just fits so well, and matching the screen prop was incredibly satisfying. J6 then came in at the end and added a bit of artistic flair that my mechanical mind sometimes leaves off. For the final print here, I decided to go for a carbon fiber look and printed it in carbon fiber PLA. When it came time to finish it, I masked off the parts that didn't need painting, and again, with J6's help, chose 2 tones of silver to give it that real life feel. As far as powering the helmet, this thing draws a lot of power, around 15 watts. To power it, I use a laptop backup battery which has 25,000 milliamp hours and can provide 20 volts at 4.7 amps. At the very least, this should provide a few hours of constant use. One of my goals was for the helmet to be motorized and open up. So I wrote all the code, tested the motors, came up with some ideas to tune the motion, but ultimately bailed on it for this particular helmet. I decided there was a decent amount of engineering to be done, and since this isn't the final 3D model I wanted, I decided to save it for a later revision. To pad the helmet, I designed, tested, and sewed a custom liner because it was such a critical part of the build. I wanted this to be comfortable and wearable for long periods of time. It turned out to be really comfortable and fits my head like a glove. Early in the development cycle, I realized I'd need to make a lot of small adjustments to the user interface. So I decided I would make the actual UI elements modular and configurable via a simple text file. This meant that small changes like moving over a graphic a few pixels would be really easy. This would also make the whole user interface really easy to redesign or reskin. Thanks to this feature, if I or someone else wanted to turn this into a different version of the Iron Man UI, create a Halo UI, or even create something from scratch, this would only require new graphics and a layout file. No need to recompile the code. Now to make it look good. The painting process was incredibly time-consuming, from choosing paint colors to all of the prep work that goes into finishing 3D prints. There's so much sanding, patching, more sanding, and patching again. Then there are the many layers of paint. And finally, the assembly process as I got ready for my first convention. At Heroes Con, it was my first time wearing the helmet in public and trying to walk around a large area completely enclosed in the tech. It was the first test of whether I'd accomplished my goals. Almost everything worked perfectly. People I showed the helmet to were blown away and no one questioned the cosplay, which to me meant I had pulled off the size requirements of the helmet. The only thing I had to abandon was the object detection, which I'll explain in a minute.
I made it. Helmet on and everything, and made it.
AC in there for a little circulation?
No, not yet.
How's the chest?
It's warm. Let's see. Is it so warm I can soften the plastic? Not quite yet.
Okay, that's good.
Yeah.
It looks killer, man.
Does it look good?
Yeah, it really does look good.
Awesome.
It looks like, you know what it is? It looks tailor-made. It looks really fit. It looks right. It looks like it's really professional.
Very cool. I appreciate that.
Put on it, everything's really aesthetically nice.
Yeah, I hadn't thought about that. If it was just LED lights, you wouldn't need much power, but because of the screen, you actually need.
Oh, this is what takes all the juice because it's doing all the processing. It's actually recording right now HD video, and it's doing
I didn't know that part.
and it's doing decode off of both cameras. Edge of the table. Ugh. There's about 34 degrees Celsius in there. So what is that? Mid-90s? Something like that? I don't know. But it works. It works.
Next was DragonCon. Here you can see how cool this looked in the helmet. Here I am with other Iron Man cosplayers, including DatBoy Builds, JT Quantum, and Atlanta Iron Man. You can find links to them in the description. They have amazing Instagram feeds. You can also see both the GPS and altitude working since I was outside and it was able to get a lock on my location. Since then, I finished up the final features I wanted. First, my abandoned object detection. It worked in the garage, but when I hit the cons and had potentially dozens of objects, my object detection would crash the helmet's code. It just turned out to be a bug that I was able to fix later, so now object detection is working. Second, I really wanted to finish up the live stream support so others could see what I was seeing. I finished that up and was able to get live streaming and recording working simultaneously. So with all that done, I finally went to a local community to test my Iron Man tech and hopefully run into some Iron Man fans. All right, here we are. We are in Suwanee, Georgia. We're in the town center area, and I'm going to walk around in my helmet, in the whole getup for the first time. I want to see how it works outdoors, how it works when it's detecting traffic and people and stuff like that, and we're just going to see how it does. So come on in here. First of all, I've got my cell phone, which is going to be the network for the whole suit. And then once that's on, I will go ahead and set up my remote viewing. I can actually at this point go ahead and get it ready for streaming. So it should be ready now. And I can start getting everything out. This contains my keyboard and the battery pack, helmet, arc reactor, it's looking good in here. You see in there? We got the NVIDIA logo coming up, arc reactor going, and the helmet is starting up. And we already have the live stream here also on the remote display. So right now the helmet is live streaming and it's recording everything that's going on. So it came up just like it was supposed to. So we get it on and we get walking around. Good? All right, let's go.
Oh, hey.
Hey, how you doing?
Nice work, kid.
The Iron Man! I thought you were dead!
I'm here.
Whoa, Ellie, move! It's Iron Man, he's here. Whoa! Say hi, Iron Man.
All right, I'm going to take a minute and then I'm going to turn off some of the on-screen stuff just to see what it looks like without so much stuff going on. I'm going to turn off object detection, that worked. I'm going to turn off some of the on-screen information, that's good. All right, so there's just a little bit less going on now. Just checking out the compass. Yeah, that's west. Cool. Let's head back towards the car. There we go, look at that. That's cool. All the cars lighting up. It'd be really cool to have a database of all of the different vehicles and then be able to look at them and it point out all the makes and models of all the different cars. All right, let's go ahead, wrap this up. That was a big success. Everything worked just like it was supposed to. All my controls worked. No software crashes, which is great. The arc reactor was able to keep me warm the whole time, which is really nice considering it is a nice cold evening. But worked great. I'm going to get this off, get it back to the garage, see what's next. And there it is. 2 years of development and a dream realized. It works really well, and it's pretty much everything I dreamt it could be. Even the experience is as cool as it looks. In fact, according to my in-software calculations, there is only a 20 millisecond delay between the time the camera receives an image until I can see it in the helmet. Near real time. This video is the culmination of everything I've been envisioning. I can finally show you what I've built. This is only the beginning. This is the heart of what I plan on being the highest tech Ironman software anyone's ever assembled. And on top of that, I'm going to make it available to anyone that wants to use it. I'll cover more on that in a future video. So if you're an Ironman cosplayer, a tinkerer, or someone that's just been inspired by all of this, be sure to follow me here and on my other social media platforms for all of the details. Before I close this out, I have to thank the makers that inspired me. The Hacksmith, who has done so much to promote Ironman and superhero hacking, and Adam Savage, whose work on Savage builds with the first titanium Ironman suit inspired me to push this even further than I had originally dreamed. And finally, J6, thank you for joining me on this project. Your graphics made all this work look incredible. If you want more of the technical details about this project, be sure to subscribe, and I'll be posting more on the channel soon. I'm Chris, and this has been Kersey Fabrications. I'll see you next time. Oh, hold on. The truth is, I am Iron Man.